Okay, question 8.1. Given f of x is equal to x squared minus 5x, determine f prime x using first principles. Okay, as soon as they say first principles, this is the only time you go to your data sheet and take down your first principles formula, which is f prime x is equal to the limit as h approaches 0 of f into x plus h minus f of x all over h. Okay, so here there's two parts to this formula. The f into x plus h part usually is f of x, but instead of x here, this part has x plus h. So this means wherever you see x in the equation, you're going to put x plus h. So we see x there in the x squared part, so that becomes x plus h all squared, minus 5 into x again, but instead of x, we write x plus h. So we have negative 5 into x plus h. Now from the original formula, we minus whatever f of x is. F of x is x squared minus 5x, so that goes in brackets there, all over h. And you keep carrying down your limit as h approaches 0, okay? So the next line, open out all your brackets, you'll end up with the limit as h approaches 0 of x squared plus 2xh plus h squared minus 5x minus 5h minus x squared plus 5x all over h. Put your like terms together, you'll end up with the limit as h approaches 0 of 2hx plus h squared minus 5h all over h. Now you can pull out your common factor of h. You'll end up with h into 2x plus h minus 5 all over h. Cancel off your h's. That equals to the limit as h approaches 0 of 2x plus h minus 5. Now this is the part where you need to substitute is not the most technically correct word, but put in 0 for h. We don't show that line, but you do it. So your final answer then, f prime x will equal to 2x minus 5 because the h is now 0. Okay, and that's that one. 8.2 now, determine 8.2.1 dy dx if y is equal to x cubed minus 1 over x cubed all squared. Okay, now dy dx means we're using the rules of differentiation, so that's all those short forms that you learned. So let's start. Y is equal to x cubed minus 1 over x cubed all squared. Okay, so this is squaring the binomial. If you look at it, there's two terms in the bracket and you're squaring that bracket, so that is squaring the binomial. When you square the binomial, you take the first term and you multiply it by itself. So x cubed times x cubed will give you x to the power of 6. Remember exponents from grade 9, when you're multiplying exponents with the same bases, you add those powers there. So 3 plus 3 is 6. That's how we get x to the power 6 as our first term. Our last term, let's just go to our last term. Our last term is negative 1 over x cubed times negative 1 over x cubed for squaring the binomial. So when you're multiplying fractions, it's top times top over bottom times bottom. So you'll end up with 1 times 1, 1 on the top. X cubed times x cubed at the bottom will give you x to the power 6 at the bottom. So our last term will be positive 1 over x to the power 6. Now our middle term there, our middle term, you multiply both the terms in the bracket, so that will be x cubed times 1 over x cubed, and you need to double that answer. So if you look on the side here, x cubed over 1 times 1 over x cubed, well, the x cubes they cancel, so you're left with 1 inside the bracket, and 1 doubled, which is multiplied by 2, will give you 2 there. So it's a negative in the middle, so that becomes negative 2. So that second line there is y is equal to x to the power 6 minus 2 plus 1 over x to the power 6. Now we can find our derivative. Oh, we're not ready to find the derivative yet. That fraction 1 over x to the power 6, we need to change that fraction into a form that we can use to find the derivative. So y then will equal to x to the power 6 minus 2 plus, make that positive exponent into a negative exponent, so that becomes x to the power negative 6. Now we're ready to find the derivative there. Dy dx is equal to, so for the first part, x to the power 6, it's going to be 6 in the power times the coefficient of 1, which is 6. then your power will be x to the 6 minus 1, which is 5. So we end up with 6x to the power 5. The next one, the derivative of negative 2. The derivative of a constant does not exist, so we forget about that one. The derivative of x to the power negative 6 now. So it's negative 6 times the coefficient of 1 in the front will give you negative 6, and minus 1 from the power, you're left with x to the power negative 7. That's your final answer for that one. 8.2.2, again determine derivative here. So dx into x cubed minus 8 all over x minus 2. Right, so on the top there, usually when you have two terms at the bottom, you need to factorize the top. So you're factorizing a cubic on the top. So cubic factorization, x cubed minus 8 will give you factors of x minus 2 into x squared plus 2x plus 4 all over x minus 2 at the bottom. Those x minus 2 brackets can cancel off, and you're left with the derivative of x squared plus 2x plus 4. Now you're ready to find the derivative, so that dx can drop off now. So x squared, derivative of x squared is 2 times 1, the power of 2 multiplied by the coefficient of 1. 2 times 1 is 2 there, minus 1 from the power, that becomes x to the power 1, or just x. So the derivative of x squared is 2x, and the derivative of the next term there, plus 2x, is 2. And the derivative of 4 doesn't exist, so our final answer there is 2x plus 4. 2x plus 2.